Hello students, this is Gokila from the Department of Computer Science with Cybersecurity. Here we are going to see about the memory management functions. After pointers, seeing memory management functions is quite easy because we are going to see about how the memory is managed among the functions and the pointers in C programming language. So when we go for memory management functions, there are three types of memory management functions like CLOC, MLOC, REALOC. And apart from that, you can also free up the memory with the help of these free. So CLOC stands for routine that is asked to allocate the arrays of memories in a particular category of allocations in the memory management function. When we go for MLOC, it is a routine that is used to allocate a single block of memory. Compared to CLOC, the MLOC is used for allocating the whole as a one. Whereas REALOC is used to extend the amount of space that is allocated previously. When we go for free, the routine is asked to tell the piece of a memory that is no longer needed at all. So the memory can also be allocated dynamically, that does not give the way to end the functions, and we must be explicitly free it up with the help of these memory management tasks. So allocation with CLOC first. When we go for CLOC, it is a special type that is used to indicate the sizes, generally an unsigned int. So when we go for CLOC, an amount of memory that is used for the CLOC is the first byte of memory that is used for allocating the function in the CLOC. And the first byte of the memory generally can also result in the appropriate type, and it is also available in C programming language with written value. When we go for CLOC, it is also a function with the standard library, that means a contiguous allocation, and it is dynamically used to allocate a particular array of elements. When we use for CLOC, the syntax of CLOC is void star CLOC, that is the size T of and size where we use a particular CLOC function. The num here is the number of elements that is used to allocate, whereas the size allocates the size of the element. So this is an example of CLOC, and we have used the keyword called as CLOC, that is allocating the size of the particular value to a memory management function. Now when we go for free, it is a prototype. The memory at a location is pointed by the pointers that is released so that we can use again and again in the future. Program that keeps the track of each piece of memory that is allocated where that memory is getting started. If we free a piece of memory allocated with CLOC, the entire array is freed, and the results are very problematic. And if we pass the address to a CLOC, the address of something is not allocated dynamically to the particular memory in the free alloc. When we go for free, we use a keyword called as nums or CLOC that particularly frees after allocation. Only after allocation you can use free. Without any CLOC or MLOC or REALOC, we cannot use free at all. So importance of free. When a function problem is called, the space of the array allocated, when the function ends, the variable goes away, but the space num points does not indicate the heap, that is no longer figure out where it is. This is what is called as the memory leakage. When we go for MLOC, the MLOC is a function in a C standard library that stands for memory allocation. It is used dynamically to allocate memory for a single block of memory. The syntax of MLOC is void star MLOC size T of size. Size is the size of memory block to allocate. MLOC returns a pointer to the starting address of the allocated memory block. If the allocation fails, it returns a null pointer. So this is an example of MLOC that does not initialize the allocated memory, that is of garbage values. It is the initialized memory that consists of CLOC when it is used freely inside a memory. So when we compare, see, it is contiguous allocation. When we compare MLOC, it is memory allocation. The next one is REALOC. REALOC is anything that it is used for function that stands for reallocation, that is used to resize a previously allocated memory block. The syntax of realloc is void realloc pointer size of new size, whereas pointer is the previously allocated memory size and new size is the new size of the memory block. It also attempts the resize of the memory that is pointed by the pointer to the new size in the new size. If the new size is larger, realloc may move the memory block to a new location. The new size is smaller, realloc may free excess memory. 2D, it cannot simply allocate it because of the pointers make each pointer to point a 1D array of the appropriate size. It also can result in a 2D array for allocating an appropriate size in the memory. So this is about the memory functions. Thank you all for listening.